Hi, my name is Will, and I've been a software developer and in the tech space for several decades now. In today's video, I wanted to take a few minutes to talk about robotics and some of the economics around them. In my last video, I talked about whether or not developers might want to think about pivoting into robotics and whether or not that made sense. And then the next day, Figure put out a video showing the latest update to the robots that they're working on. As I'm watching the video, I keep thinking about cost. How much are these going to cost? And what are the economics around when it makes sense to actually replace a person doing a job with one of these robots? That brings us to trying to come up with both a ballpark for how much these things might actually cost and what would be reasonable for businesses to pay for them. At the starting point, you've got the brain of the machine. From the video, it looks like it's running a very solid LLM to operate the machine. And in the diagrams, they sort of talk about how it's the brain that kind of coordinates things. And then there's other components that are actually executing the commands. Just by way of reference, a top of the line Mac Studio, if you maxed out the memory for that, is around $6,000. Let's round it up to 10 for regulation and some other pieces. It's just not that much money for the brain. We've gotten cameras down to where they're pretty inexpensive. The electronics on the arm are super fascinating to me, but we just don't have details on what it looks like. But as a way to kind of get a reference point, we do have a couple of examples for the body. The most obvious one is, of course, Boston Dynamics. Now, Boston Dynamics has two robots that most folks are aware of. One of them is the Spot Dog, which costs around $75,000 from what I can tell is a baseline from reports in the press. They're only available through enterprise sales, so you have to call them up to get pricing. You can add on additions to the Spot Dog, which most interesting to me, of course, is the arm that you can use that is articulated to be able to do things, but they've got other kits and accessories that'll get you up to the $200K price point. Atlas, which is the humanoid robot, is as of today just strictly a lab R&D figure. They haven't announced any sales options or anything like that, so nobody can buy it. I did some more research and I did find a Chinese company that's offering robots as well. Now they have their own little tiny baby version of something that's kind of like the Boston Dynamics Spot Dog, but it's almost like a drone version of it, and that's only $1,600. The Chinese site also has a humanoid robot, which they're offering for about $150K, which is kind of wild to me that someone would just go to a website, click a button, and order a $150,000 robot from China, but I could see some people wanting to do that. Now we've got some price points. We know if the Spot Dog can run anywhere from $75K to $200, if this firm in China has one that they're listing for $150K, you start to kind of get a ballpark. Let's just say for the sake of discussion that the Figure robot, once it's actually shipped and available, will go for anywhere from between $500K and $1 million, just to kind of start with. So $500K or $1 million sounds like a lot of money, but remember you get to finance this. At a 5-year loan with 8% interest, it works out to a little bit over $10,000 a month, $500K, or a little bit around $20K a month if it's $1 million. To compare that to human labor, remember, the robot can run presumably 24/7, and if it can run multiple shifts, that's equivalent to more like 3 to 5 people. So to put it in context, let's just say it costs $1 million for the robot. If it's financed, and that means it's $20,000 a month for the robot, but it can replace 3 to 5 people, you start to see where the economics get really interesting. If the robot's $500K, that's only $10,000 a month. In addition to that, the business is also presumably going to get tax breaks for the interest and for the loan, and then also asset depreciation. So there's a lot of tax advantages that come to the company, whereas if you hire an employee, you have to pay not just the salaries, but you also have to pay things like, depending on where you are, unemployment insurance, workman's comp, all those kinds of things. You start getting to this point where the economics suddenly do start to look pretty good for a business, and I could see where they'd be pretty interested in it. That doesn't count the opportunity side too, which is if those robots cost $1 million, but they've got pretty good margins, that means that the business could be making a lot of money pretty quickly once they start getting these things ready to ship. And remember, if you buy a robot like this, just like a car, if you buy it and then you use it and then you turn around and you want to sell it later, you can recoup some of your money. So once the pipeline starts flowing for this stuff, you start getting, just like the car market, you'd have more expensive new ones, maybe eventually start getting cheaper older ones that are a little bit banged up, but you can start to see this whole market evolving around these things. Obviously, if you're paying any attention at all, the first thing that you think about is what is this going to do about jobs and employment? We know that the Great Depression or Weimar Germany, around 20% unemployment, those numbers you start hitting, and you start having huge social challenges and problems, and bad things happen. I mean, bad things happen when unemployment gets to 10%. What happens when it gets to 20% or 30%? We do have time. I mean, these robots aren't available yet. You can't buy one yet, and they're tech demos still. Both the Figure robot, the Atlas robot, these things only exist in labs right now. But that said, it could be a couple of years from now and we can start seeing these things being deployed. I think that for me, at least, part of the takeaway was that once I started putting these into math, especially including the financing model, I'm starting to realize that these are a lot more, frankly, commercially viable than I thought they might be at first. At first I was like, humanoid robots, what, why? Doesn't necessarily make sense. But yeah, if you can start financing and putting them into your factories, it does make sense. With that in mind, I originally was going to have the next video talk about UBI, because that's one of the first things that people start talking about as soon as you start talking about the economic impacts of this. I decided to go ahead with this one out first. I'm still going to work on the UBI script because I want to do a good job with the script. I want to make sure it's tight. And so I'm going to take the time to make sure it comes out well. It's not a panacea, and there are a lot of challenges to it. And so in the UBI script, I want to talk about what does it mean? How much does it cost? Does it make sense? And then frankly, what are some of the metrics that you'd expect to see for how bad, for example, unemployment might get before you'd see popular political support? So I want to kind of do a more grounded data and facts-based video about that one. So the other thing I just wanted to note before I go is that I've been really blown away by the quality of the comments that I've been seeing people posting. Like on the last video about robotics, people who work in that field have been chiming in with their thoughts about it. And then there's also a lot of folks that are talking about their experiences with the economy right now. I highly recommend, if you got a chance, check out the comments, chime in. I've been hopping on and getting to be a part of that, and it's been really fun. So appreciate that. This is a lot to process and think about. And so, yeah, with that in mind, hit the like button and subscribe and the bell and all that stuff. So thank you for your time. Take care, and be back soon.